Welcome back, everyone, to creating building peak loads with Trane Trace. I need to change that title. I always get it wrong or stumble over it. So I wanted to continue our talk about HVAC systems, and I'm calling this segment Special Systems. So before, when we were looking at Trace, we just picked an air-based system and assigned all our zones to it so we could run the model with the least intrusions by the system. And now I want to spend some time and look at a few other systems that can be put into Trace and talk a little bit about why you would want to do that. So if we go back in here into creating systems, first off, the main one that might be the easiest one to make would be fan coils or something to that effect. So often I'll just pick all systems. Here we go, and then fan coils. So this can be useful if you have a fan coil system, and if you want to see, now each zone has its own heating and cooling element. So that's nice. There's not much more, let's see, to the fan coil. We now have, each zone is now sized to its thing. The more interesting ones are the either induction units, or they also have chilled beams. This system has a zone level cooling coil. You should create one or more zones under assigned room. Oh, I see. Oh, it looks like we have to make thermal zones in order to use this. So chilled beams. Okay, so let me back up here. 80% of the time, I would recommend that people do their peak calculations in Trace and then break up the loads if you have a radiant system or a chilled beam system and a dedicated outside air system outside of Trace. It's a pretty complicated thought exercise to figure out how much cooling is my fresh air doing and how much cooling is my room air or my room cooling element contributing. In the scenario of a radiant system, in a humid climate, the ventilation air actually is the dehumidification component as well. And so on your summer days, your fresh air is actually wringing out moisture, because it has to, from the ventilation air. And inherently from doing that is often rather cold. And so you will sometimes get more cooling than you would need to as you're working through a design. Which could almost beg the question of, well, maybe we should reheat the ventilation air. I would highly recommend not reheating anything, if you can. So that's all fine and good, but why are we talking about this? So sometimes this all comes back to when you have a distributed cooling system, cooling system, and we need to size each room both for its cooling manifold, and then we also need to size the cooling coil at the roof level, which is you size for ventilation air and then more air if needed for additional cooling. We really need to know the load in each room for that room, and then we need to know the coincident peak of the building when the ventilation coil is needed, and we need to make sure that on that hour when we're trying to size the building's main air handler, each room is only using the amount of its individual radiant element as it needs to. If we were to post-process this and say, well, at the building's peak, each room is able to do 15 BTUs a square foot of cooling, there may be some rooms that don't use their full 15 BTUs of square foot of cooling on the north or on the east. And there might be some rooms on the west and the south that need a lot more cooling than that, because that's where the sun might be, and maybe those rooms are peaking around 20 or 30 BTUs a square foot. And so it can be risky if you just size the entire building after running the loads and say, well, all the spaces, we're first going to say the radiant contributes this much, and whatever is left over when the building peaks is the size of the coil for the air handler. If you did it that way, your coil would likely be undersized, maybe by 20 to 30%, enough that it's noticeable. So that calculation can be done in a few ways. How to actually break this problem out can be done, it could be done in Trace if you are aware of how to use Trace in a little more advanced way. And that's what I want to talk about. So if we knew the design capacity, if we picked a design capacity of our local zone-based cooling element, in this scenario I'm picking passive chilled beams, but essentially the same mode of heat transfer will work. We're going to have some room, be able to relieve some amount of heat. The way we would take credit for how much cooling that room level element can do is underneath this auxiliary cooling capacity. By default, it's set to be 100% of the remaining load that the ventilation is not able to provide. However, if we really want the ventilation to be oversized, or if we want the main unit to upsize in case it needs to higher than ventilation, which is a very common desire, we really want these auxiliary coils, these radiant slabs, or these, in this case, passive chilled beams, to be the first line of defense in managing our peak load. So in Trace, it would be possible, you can put in a BTU per square foot that can be provided to this room. So let's say our slab was able to do 18 BTUs a square foot. If I hit apply, I then want to say, okay, my main cooling coil is actually going to do 100% of the design minus the auxiliary capacity. Oh, this auxiliary got changed again. You have to be careful of how the numbers get set. Okay, so now I think I might be set. I haven't changed heating. Let's focus on cooling. So what's now going to happen is this is going to go first. And this is going to say, figure out how much cooling each room needs. And if it's below 18, then the fresh air will just be sized based on fresh air. And there will be no cooling oversizing. Yet now, when it sizes the whole system, there may be some rooms that don't hit their 18 cooling load capacity, and that's fine. Those zones won't contribute to oversizing the main air handling unit. More importantly, though, those zones that are not peaking and not overgoing their 18, those slabs won't contribute any cooling load to a slab that is peaking, because physically that couldn't be. A west zone could not transfer its heat to a north zone. So this setup is now going to give us some control. The problem, or not the problem, so this would actually work. So now if we ran this and we looked at the different reports, it would work in the capacity we want it to. Often though, this capacity of the slab is a dynamic one, or a dynamic design parameter. It's actually a static. At the end of the design, it's static. You know, we pick a certain design, we pick a size of tubes and a depth of concrete, and it works. And we know it always works. And we put in, and we take account for the risk of the likely cooling per square foot that could provide. But when we're in design, 18 might be a fluxing number. Your principal in charge might say, hey, well, what if we had 22? I think we could do that with a higher tube size. What's our load now? Well, in that scenario, that could be a really hard thing to rerun if this trace load has to feed into multiple other spreadsheets which aggregate the load. So the design question may be a reason to not do it this way. The speed of change and the speed of design may inhibit this method. But that is something you could do. So I think also in here, let's see if they have the other system type I was thinking of. They do. Okay, they do have variable refrigerant volume. I haven't dug into this a lot, but again, this could be a useful thing to use if you do have a VRF system. There may be some more options. Doesn't look like there's a ton. I guess the most might come under advanced options. Oh yeah, this is where. Oh yeah, let me show you the. So VRF does exist. Let's go back to chilled beams real quick, and let's leave it on active chilled beams. If we go to the advanced options under the options tab, this is where you can actually see what we are picking. So this is where we could say we have an active chilled beam, or we have a fan coil or something else. So if you wanted to pick, I think if you do passive chilled beam, and then we go back here, you could pick, for a while I thought, alright, well, there are ways. Check out the Advanced Options tab. It's more useful than you might think. So those are some advanced systems, and let's keep moving with how to run, trace, and look at results.